All right, example 3, you will notice this is not a triangle. Instead, it's a trapezoid. This street is parallel to this street. The way they word the words up here tells me they're parallel. So if I read it, it says reflecting pools separated by walkways parallel to Lincoln Street and Jefferson Street. So if the walkways here are parallel to both streets, that means all those things are parallel to one another. So I've got a bunch of parallel lines happening here. Let me just highlight that real quick. Thinking blue will show up nicely. Let's see if I'm right. It's not bad. So there's Jefferson Street, parallel to that walkway, parallel to that walkway, parallel to Lincoln Street. All right, so all those are parallel to one another. Now the side splitter theorem has a corollary to it, which means that, hey, this is what the theorem says, it's about triangles, but we can use that theorem in other figures as well. And what the corollary states is this. If you have multiple lines cut by multiple transversals, multiple parallel lines cut by multiple transversals. So specifically what we're looking at here, I'm going to say red might show up well too, let's see. I have this piece here is a transversal to all those blue parallel lines, and this piece here is a transversal to all those parallel lines. If I keep extending those lines, eventually they make this triangle, right? We don't have to see the triangle to use the side splitter theorem, though. These are parallel, these are parallel, these are parallel, all these are parallel, so the pieces in between the parallel segments are proportional to one another. So what I'm saying is that this little piece and this little piece are proportional to this little piece and this little piece, which is proportional to this little piece and this little piece. Any proportion we want to make with those is legal. All right, so with that in mind, it says the city wants to add additional tiling around the pool. How much tiling does X feet represent? So they're trying to find X here, which is right here. And I know in this part of the picture all the numbers except for X, so that's enough information to figure out X. X and 24 go together. X and 24 go together. 60 and 72 go together. X and 60 are on the same transversal. 24 and 72 are on the same transversal. When you make your proportion, make sure there's something common about everything in the proportion, both horizontally and vertically when you make the proportion. So X and 24 are proportional, they're both on top. 60 and 72 proportional, they're both on the bottom. X and 60 are in the same transversal, they're in the same fraction. 24, 72, same transversal, same fraction. So when you're making that proportion, make sure all those agreeances happen. And then we just cross multiply to solve. So I get 72 times X equals 60 times 24. And if 72x equals 1440, we divide both sides by 72. We get x equals 20 feet. So the general purpose of this whole lesson, chapter 7, 5, day 1, is this side splitter theorem. Overlapping triangles with parallel sides in it that allow us to use the side splitter theorem. Also leads to parallel or similar triangles. So use those properties in order to create proper proportions that allow you to find missing segments.